Hello, ladies and gentlemen. Okay, so today's lesson, what we're going to be doing here is we're going to learn how to do some calculations as the following. There we go. So this question says, how many moles of iron, Fe is iron, in 8.3 times 10 to the 24th atoms of iron? So you have a certain number of atoms of iron. You're going to want to find out how many moles that is, right? We talked about the mole. We talked about, grouping atoms into moles. Okay, and we're going to use, well, one of the things that we could do is we can use this mole diagram here. Um, some people call it the mole diagram. Other people call it other things. I can't remember what it is right now. But basically, right here, this here shows this is the mole. Remember that each one of these um, diagrams here represents, or these drawings or figures represents a different quantity, a different number that you can calculate. So here's the mole, and it's in the center. Over here, representative particles. In this case, representative particles. Whoops. Let me draw with representative particles. In this case, are going to be atoms, because what we're going to be working with is elements. Elements are made from atoms. Okay, and so really, representative particles. In this case, these are going to be atoms right here. These are going to be atoms. Next week, these may represent molecules, but right now we're going to be dealing with atoms because we're just working with elements. And so we can convert between atoms and molecules. We can have a certain number of atoms and turn them into moles. And we can turn moles into atoms. I said molecules earlier, I meant moles. And we're not doing anything with molecules until next week. And what this diagram here does is it tells you what the conversion factor is that you need to use. So when you are given atoms, you want to find out how many moles. See this right here? Okay, this thing right here, this thing here is telling you that this is the conversion factor you need to use. You put 1 mole over 6.02 times 10 to the 23rd particles. Remember that the conversion factor is 1 mole equals to 6.02 times 10 to the 23rd of, in this case, we're going to be using atoms, right? Particles is a more general term, but when we're being specific with atoms, put down atoms. So this means that when I have a certain number of atoms and I want to turn them into moles, I divide. Notice how the 6.02 times 10 to the 23rd particles, or atoms, as I would put in this case, is in the denominator. Okay, so going in this direction, here, you divide by 6.02 times 10 to the 23rd, because every 6.02 times 10 to the 23rd is grouped as 1 mole, right? So if you have more than 6.02 times 10 to the 23rd, you're going to find how many groups of 6.02 times 10 to the 23rd you've got. Now, if you're given moles in the problem, and there's another problem over here where you'll be given moles, how many atoms in 0.23 moles of chromium? Well, then you're going in the opposite direction, and you use the inverse of it. Okay? This one right here going in this direction right here, use this conversion factor. Now you don't have to have this mole diagram. You just, as long as you know 1 mole equals 6.02 times 10 to the 23rd atoms, then you can make a conversion factor by either taking this side divided by that side, or this side on top and this side on the bottom. And that's your two options. And whichever one cancels out the units, that's the one you use. One of them you'll cancel out units, the other one you don't. So 2 of our problems will be like that. And 2 of the other 2 sample problems, I have 4 sample problems here to show you, are between moles and grams. All right. So when you want to turn moles to grams, notice this right here, you're going this direction. So you use molar mass over mole. And remember that the thing about turning moles to grams, that a mole of one element is different than a mole of another element. So what we call the gram molar mass, the molar mass in grams, goes on top here, divided by 1 mole. And when you're turning grams to moles, you divide by the molar mass, right? Notice that the molar mass here is in the denominator. Okay, so this is how we're going to use it. Let's do one here first, and we'll see how these go. And these are basically all types of conversions that we have on this worksheet. So let's go ahead and do the first problem. So once again, how many moles of iron in 8.3 times 10 to the 24th atoms of iron? So I know that for any element, 1 mole equals 6.02 times 10 to the 23rd atoms. If you know this already, you don't have to write it. I'm putting it here to remind us. So this is the equality that's going to give us the conversion factor. What we're given here, and I'll do this in green, is we're given 8.3 times 10 to the 24th atoms. All right, so let me go ahead and write that. That's my given. 8.3 times 10 to the 24th atoms. And it's specifically atoms of iron. Just to be complete, I put all my units in there because eventually my units help me do the problems. Now I'm going to go ahead and multiply that by a conversion factor created from this equality because I'm given atoms. Go ahead and put blue. I'm given atoms and I want to end up with moles. So I want my atoms to turn into moles. I'll just way over here. Trying to make a little arrow here. Well, you get it, right? Let's go in this direction. I'm given atoms. I want to turn it into moles. So I'm going to make a conversion factor here where my atoms of iron are going to cancel. So if I look at my equality here, one side is going to go on top of my conversion factor. The other side is going to go on the bottom. Which one goes on top, which one goes on bottom, really depends on the units. So here I have atoms. So I'm going to put the side in the equality, I'm going to put the side of the equality that has atoms in it so that the atoms cancel out on the bottom of the conversion factor. 6.02 times 10 to the 23rd. And the other side goes on top over 1 mole. And now I can go ahead and do my calculations. You'll notice that the atoms cancel. Even before doing the calculations, my atoms cancel. The only units they're left with are moles, which is what I wanted. I wanted moles in the end. So in order to calculate how many moles I've got, I'm going to take 8.3 times 10 to the 24th times 1 divided by 6.02 times 10 to the 23rd. Let me go ahead and do that in my calculator here. I'm wondering if I should do it. I don't even know if it'll come out. So 8.3 times 10 to the 24th. See that? 8.3 times 10 to the 24th divided by 6.02 times 10 to the 23rd. That's going to give me, I'm going to say 13.8. 13.8. Okay. Now, well, you could see that it's kind of a small thing. So basically, we're going to get 13.8 moles of iron. Okay. So we're left with moles. I just kind of follow this. Moles ends up over here. And since we're going to be specific, which moles of what? Moles of iron. Okay. And there's my answer. Okay. So that's how you do it using a conversion factor. And what this is telling me is that if I had 8.3 times 10 to the 24th, how many groups of 6.02 times 10 to the 23rd? And so 10 to the 24th is, one order of magnitude greater. So, there had to be at least 10, right? Because 6.02 times 10 to the 24th would be 10 times bigger than 6.02 times 10 to the 23rd. Right? So this was bigger than even that. So you figured it'd be something this large. Now, just to let you guys know, this is not the only way you can do this problem. There are other ways, and they're mathematically just as valid, except that this is just a one-step problem. Later on, we're going to do multi-step problems, and this conversion factor thing makes it much easy, really pretty easy to do. However, um, you know, some people work better with other stuff. So in this case, what I'm going to do is I'm going to go ahead and show you an example of, oops, sorry, wrong. I'm going to show you an example of another way to do it. And there are more than two other ways. Let me go ahead and duplicate this and put it down. Okay, so move it this way and one more time. Oh, that is a shame. I thought I could continue moving it down. All right, well, let's just move it up a little bit here. I'm still messing with this, what I can get away with and what I can't. All right, so another way you can do it is by doing proportions, right? Basically, you go, let's see, we want moles in the end, right? So we know that for every 1 mole, there's 6.02 times 10 to the 23rd. So you make a proportion by putting a fraction on the left and a fraction on the right. And on the right, what you do is write down what you're given, the 8.3 times 10 to the 24th atoms. 8.3 times 10 to the 24th. My x's are just not complete. Atoms. So if 1 mole has 6.02 times 10 to the 23rd atoms, x, how many moles, has 8.3 times 10 to the 24th atoms. And so as you can see, it just becomes an algebra problem where I'm just going to go ahead and solve for x. And I'll multiply both sides by 8 since I want to get x by itself. 8.3 times 10 to the 24th atoms. Okay. But whatever I did to this side, I have to do the other side, right? So 8.3 times 10 to the 24th atoms. All right, now the atoms cancel here. And what you're left with is that x equals to, x is by itself on this side, 8.3 times 10 to the 24th divided by 6.02 times 10 to the 23rd, which is pretty much the same thing that we did earlier, and that's 13.8. And once again, the atoms cancel, we're left with just moles. And moles of iron, I guess, let's say. So this one would work also, right? Notice it gets the same answer. I didn't mess that up as this one over here. Okay. Because essentially what we're doing was we're streamlining the proportions here. We're streamlining a proportion. It's really the proportion, right? Notice 1 mole over 6.02 times 10 to the 23rd. And over here, you're also using 1 mole over 6.02 times 10 to the 23rd. And when you do a proportion, you have to have atoms both. It doesn't matter whether you have atoms on top or on the bottom, you would have got the same answer. But it's easier to have the unknown in the numerator, so you don't have to like bring it up to the numerator or cross multiply. Adds another step. So if we're looking for moles, I put the 1 mole on top, I put the atoms on the bottom, and then on this side, I put the x on top. And this is our given, right? This right here is our given, what we're given in the problem. Sorry. This is our given we got here. Okay. So either way, you can do those. That's the only time I'm going to do the proportions example, though, because I'm kind of pushing for the conversion factors. Why? Because I know what's coming up. I know how we're going to use these in the near future, and I know that using the conversion factors method, mathematically they're identical, really. But the setting up with the conversion factors makes it much easier. All right, so let's do another one. So here we turned atoms into moles. You're given atoms, you turn them into moles, which is what we're doing over here. You're given atoms, you turn them into moles. And once again, notice the conversion factor, 1 mole over 6.02 times 10 to the 23rd particles. I didn't have that memorized. What I did is I created the conversion factor, and it works, even with feet and yards and all that stuff. You have the equality, you create the conversion factor. You create this conversion factor from the equality, by just making sure that your units cancel here. Atoms cancel atoms. Okay. So you don't need this chart. If this chart helps you, so be it. And there's a chart like that in your book. There's also the PowerPoint PDF that I put up. The last slide is this chart, not all this gobbledygook that I wrote in here. But if it helps you, great, especially at the beginning. But you can make it on your own. Now let's go to this one. Okay. Now, how many atoms in 0.23 moles of chromium? So the last one was you were given atoms and you want to find moles. This one here, we are given, I'll go ahead and once again do the green. We are given moles and we want to turn it into atoms. All right. In other words, according to this one, we are starting here and we want to move over here. Oops. So we're going in this direction. And here it says we're going to multiply by Avogadro's number. Where was I? Yeah, so here we are. So let me go ahead and write down. First off, write out my given. And this whole thing is my given here. Let me go ahead. Circle it. It's the number and the units that come with it. Okay, so I'm going to write it down. And if you're disciplined and you don't just put the number but put down the units, I don't know why students hate using units. It's like it saves you like 2 seconds, but those units tell you what to do. Right? So write down both the number and the units. I mean, the laziness really gets in the way of a lot of people learning how to do this and using this method, and then it gets in the way of test scores and stuff. All right, so this is our given. Then we're going to write the little cross. And really, once again, it's not really a cross as much as it is two fractions next to each other. And once again, a reminder that I never write anything down here unless there is actually a fraction. And understood that it's a 1. Then I use my equality again, and I forgot to write it down, but same thing. 1 mole equals to 6.02 times 10 to the 23rd atoms. Okay, so I want moles to cancel this time, right? I'm given moles, so I want the 1 mole side of the equality to go on the bottom. I want the 6.02 times 10 to the 23rd atoms side to go on the top then. The other side, top. 6.02 times 10 to the 23rd atoms. Okay, so now we can see that the moles cancel. And you get 0.23 times 6.02 times 10 to the 23rd. So let's go ahead and do that in our calculator. 0.23 times 6.02 times 10 to the 23rd. Okay. That gives you 1.39. Since we have two significant figures over there, we'll say 1.4. 1.4 times 10 to the 23rd. The answer, 1.3846. Rounding it to 1.4. Really, we're supposed to use significant figures here. 1.4 times 10 to the 23rd. Okay. And they're atoms of chromium. So basically, my units were atoms of chromium. And there's your answer. Go back to black here. All right, so 1.4 times 10 to the 23rd atoms of chromium. That 3 looks pretty ugly, so let's do that over again just so that people aren't confused by it. Okay. I don't know if that's much better, but it is better. I don't know if it's much better. Okay. And you will notice here that the conversion factor that we used is just the inverse of the other conversion factor. Here we turn moles to atoms, and we use 6.02 times 10 to the 23rd atoms over 1 mole. This previous one, we turned atoms to moles, and we use 1 mole over 6.02 times 10 to the 23rd atoms. And that's what this chart here is telling you. If you go from atoms to moles, you use 1 mole over 6.02 times 10 to the 23rd atoms. And if you go from moles to atoms, you use 6.02 times 10 to the 23rd atoms over 1 mole. They're just the inverse. All right, so that's how you go back and forth between moles and atoms. Now let's go ahead and go on this side over here. Let's do a problem like this one. This is problem number 3, by the way. I should put them up here. That way you kind of know on the video when I'm doing one of the problems versus another one. So how many moles of magnesium in 100 grams of magnesium? So we have 100 grams of magnesium. You're given grams. So going back over here to this thing. You're given grams. You're over here. You're going in this direction. You're asked for moles. Okay, you're going from grams to moles. So your conversion factor is going to be 1 mole over the molar mass. Okay, and let's see how we do that. I'm going to write down my given. These, by the way, after a while can be done pretty quickly. It takes a while to go ahead and explain everything. And we want to convert. Here. We're given grams. All right, so we're given grams. We want to convert them to moles. So we want a conversion factor that turns grams and moles. We want a conversion factor that's grams and moles. Okay. Now, if we look at the periodic table, let's go ahead and look at the periodic table. We're going to look up magnesium, and we're going to look up the atomic mass. Okay, if we go to the periodic table, and I'm going to go ahead and make this bigger. Magnesium's atomic mass, as you can see over here, is 24.31. And remember what that means. The atomic mass can both be taken as the average atomic mass, the average mass of a atom of that element, or it could be taken as the number of grams in 1 mole. Okay, and that's what we're going to use right now. So according to the periodic table, 1 mole of magnesium weighs 24.31 grams. 1 mole of magnesium, I'll write this down here. 1 mole, oops, sorry. Sometimes I hit that button and it gets stuck there. 1 mole of magnesium equals to 24.31 grams. Okay. And once again, that's where we got it from. We got it from right there, 24.31. We get it right from the periodic table, right in the box. Got to use the periodic table. All right. Where was it? Okay. So this is going to be our equality now that we're using to make the conversion factor. This was our given right here. The 100 grams was our given. Okay, this is what we're going to use for our conversion factor. So for the conversion between moles and atoms, the conversion factor is 1 mole equals to 6.02 times 10 to the 23rd particles, atoms, all the time. For the conversion between moles and grams, you have to look it up. And in order to get grams to cancel, notice that we've been given grams. In order to get grams to cancel, this side of the equality, 24.31 grams of magnesium goes on the bottom, and the other side of the equality, the 1 mole of magnesium goes on top. And so now you'll see that grams of magnesium cancel out grams of magnesium here. And in order to get moles of magnesium, you have to take the 100, multiply it by 1, which is 100, divided by 24.31. So let's go ahead and do that. I'll take my 100, calculator 100, divided by 24.31. That's going to give me 4.11. 4.114. Just trying to get that centered there. 4.114. It's harder than I thought to hold this. All right, 4.114. And that's our numerical answer. And our units are in moles of magnesium. So every 24.31 grams is 1 mole. We have more than 24.31. We have 100 grams, which is, you can see, 25 would be a fourth of 100. So 24.31, multiply that by 4, it's going to be a little less than 100. So that's why we had a little extra there. And here I was following my significant figures. 4 significant figures here, 4 down here. So I end up leaving 4. It's not, the end all be all, but it's important to kind of get going. So I wanted to turn grams to moles. So we needed to get the conversion factor that grams and moles in it, which is the atomic mass, the gram atomic mass. Remember that this number right here, this is the atomic mass, okay, is what will be 1 mole for this element, magnesium. Why? Because that's the number on the periodic table for magnesium. Okay, you really want to get more into how they figured that out. I really have decided not to get into it because it confuses people more than they're already doing. There's a definite explanation having to do with proportions of atomic masses between one element and the other. I just decided not to get really into it. I usually don't do it because it confuses people. But people who are interested, I'm happy to talk to them about it. Go a little deeper. All right, so this problem allowed us to turn grams to moles. Right? So we went from grams to moles. Right? We did, right? Yeah, grams to moles. This last one's going to ask us to turn moles to grams. It's going to give us moles and ask us how many grams there are. So basically, we're doing the last one here. You're given moles, how many grams are there? Keep doing that. So we're going this direction. Here you have to multiply by the molar mass instead of divide. Last time, notice that we went from grams to moles. I might have said it wrong before at the beginning of the problem. Hopefully that didn't confuse people. We went from grams to moles. So we divided by the molar mass. This time we're going from moles to grams, and we're going to multiply by the molar mass. I think I meant to put them in the opposite direction, but that's all right. So once again, what is our given? Our given is the given quantity is the number you're given and its units, 4.83 moles of tin. And it's important to note that it is tin, even if you don't write it down, because we're going to have to look up the atomic mass of this element. So it's good to know it's Sn, which ends up being tin, 4.83 moles. Notice the abbreviation here is MOL. It kind of cracks me up because, the whole word is MOLE, right? But we can't use M because M is meters. MO, just MO would be months. MOL is, well, that's the smallest, we got. So all we're doing is taking off an E. 4.83 moles of tin. And now we need the conversion factor, right? We are given moles and we want to turn it to grams. The question is asking for grams. We should have grams at the end. We want to turn our moles into grams. So once again, we need to go onto the periodic table, and let's go ahead and go to the periodic table and find tin. And in the interest of time, I'll show you where it's at. Tin's down there in the bottom right. Right, and tin is got an atomic mass of 118.71. That means that 1 mole of tin has a mass of 118.71 grams. Every mole of tin weighs 118.71 moles, if you want to think about it that way. So let's go ahead and we already did that one. Go over here. So I'm going to write this down over here. 1 mole of tin equals to 118.71 grams. Okay. Once again, we're given moles. The question is, which side of the equality do we put on the top and the bottom? And as you already know, I like starting my conversion factors from the bottom because that way I notice which ones get canceled. So 1 mole of tin. I'm gonna put 1 mole of tin. I'll abbreviate it just so it matches. 1 mole of tin goes on the bottom. The other side of the equality is 118.71 grams. Grams of tin. That's going to equal to, and once again, the moles of tin cancel out. Once again, you can do all these with proportions also, as long as you understand it. This is a proportion. It's just kind of set up in a different way. All right, so what we're going to have to do is, since they're both in the numerator, just multiply. 4.83 times 118.71. That's going to give me this number. So we got 573, and I give 3 significant figures. So we'll take 3 significant figures at the end. 573.3693. So I'll just put down 573. Technically, that's the way we should do it. I didn't think about significant figures making of these sample problems, but so 573. You know what? Let me make that prettier. 573. Right. And we're left with these units here, grams of SN. All right, and there is your answer. So that's how you do all of these, okay? And so these are what we call one-step problems. Go back. When you make the conversion from atoms to moles, it takes one step, one calculation. When you make the conversion from moles to grams, that's also one step. Right? So on your worksheet that you're going to be doing, there is the first page is all one-step problem. You turn atoms to moles or moles to atoms. Or you might turn moles to grams or grams to moles. And it's going to look like one of these 4 problems. Okay. By the way, I forgot to mention, and when you go to these two right here, these last two that between grams and moles, moles were grams. I don't want to say that they're the conversion factors are complete inverses of each other because we're using different substances. But you'll notice here for the problem where we turn grams to moles, we had the mole of the substance on top and the grams on the bottom. And then when we turned moles to grams, it was the other way. We had the grams on top and the moles on the bottom. Right? Oops, I forgot to turn that. You get it. You get the idea. Right? There we go. All right, so that's how you do it. Now, some of your problems will be what we call two-step problems. And all two-step problems is, all right, I'm telling you how many atoms you've got, giving you how many atoms you've got, how many grams is that going to be? Or I'm giving you how many grams, how many atoms you're going to get. And all it is just taking the one step from grams to moles, the next step moles to atoms. Okay. Actually, let's go ahead and do one. And basically, this is, like I said, counting by weighing. I'll do one in just a little bit. Actually, I'll do it right here. Okay. All I need to do is open up a new one here. We're getting on in this video, but you know what? If the video falls apart right now, at least I'll have the earlier part. What do I need? I need. Okay. All right. So let's see. We're going to do this one. How many atoms in 0.382 grams of silicon? Okay. So in this problem right here, you start off given 0.382 grams, and you want to end up finding out how many atoms, grams to atoms. We go back to our table right here, and let me get it small, a new one. I actually have another one. You were given that you were given a certain number of grams, 0.382 grams. So Let me go ahead and change the color here. 0.382 grams. The question is, how many atoms? And you'll notice there is no direct link right here between grams and atoms. What are you going to do if there's no direct link? Well, you go the long way around, right? You turn your grams to moles. Then once you have moles, you turn them into atoms because you can get how many moles there are from knowing how many grams of an element, right? And then once you have the moles, you can turn those into atoms. So let's go ahead and do that. First thing is turn grams to moles. So I'm going to go ahead and, first off, this is what I need to know. I need to know, this is silicon, right? So I need to know what is the molar mass of silicon. Let's go ahead. Sorry, the atomic mass of silicon. So we're going to see that we use those interchangeably. Go to the periodic table. Whenever grams are either given or asked for, you're going to look on the periodic table and you're going to look at the the atomic mass. We call it the molar mass because it's the mass of 1 mole. So atomic mass for silicon is 28.09. Okay. Now that we know that, we can go ahead and do our problem because we know that 1 mole of silicon equals 28.09. And then, by the way, this is problem number 5. Gram. Okay, so we know the relationship between it. Now we can go ahead and write down our given 0.382 grams of silicon. Write the conversion factor. So here's our given. We write it down our conversion factor. This equality, remember, comes from the periodic table. We want grams of silicon to cancel out. So 28.09 grams of silicon goes on the bottom, right? That's just the right side of this equality. The left side of the equality goes on top. 1 mole of silicon. That equals to 0.382. Very small. This is like 382 milligrams. 0.382 divided by 28.09. And I get, can't even hold on to the, here's there. 0.382 divided by 28.09, 0.0136. So 0.0136. 0.0136. And that ends up being how many moles of silicon. So the grams of silicon cancel here and here. We did that on purpose. 0.382 divided by 28.09 is 0.0136, which is a small number, but it's rather valid. And even in a small amount of moles, there's a huge number of atoms. Right? We're not done yet. Our problem asks for atoms. We got to turn moles now into atoms. And so what I'm going to do is I'm going to go ahead and rewrite my given here. Although I guess I could have just continued it on this side, but I decided to write it all out here so you can see it. Normally, if I just had a piece of paper, I would have continued on this side. Then that's why one of the reasons I like this method. Okay. How many atoms in there? Well, once again, we know, and I'm not going to rewrite it, but we know that 1 mole is 6.02 times 10 to the 23rd atoms. So 1 mole is going to go on the bottom, so the moles cancel. 6.02 times 10 to the 23rd atoms goes on top. Okay. So what this is telling me is I need to take 0.0136, multiply it by 6.02 times 10 to the 23rd. I'm going to do that again with my calculator. 0.0136 times 6.02 times 10 to the 23rd. And what I get is this number, 8.19 times 10 to the 21st. 8.19 times 10 to the 21st. Answer. That's still a heck of a lot of atoms, right? It's only like 382, not even a gram. It's a third of a gram. And in that third of a gram, there is 8.19 times 10 to the 21st atom. silicon. Move this over here. Oh, it's getting in my way. And there is your answer. Forgot. Lock it in. Okay, and that is atoms right here, right? That's what we wanted. We wanted atoms. Okay. So that is a two-step problem. You convert grams to moles, and then moles to atoms. And if I go back over here, just to show you that that's what we were thinking of doing, turn grams to moles. That was the first step. Then moles, turn them into atoms by multiplying by Avogadro's number right there. And that's what we did. We multiplied by Avogadro's number. So I hope this has been helpful. All your problems are basically done like this. Whenever you're converting between moles and atoms, remember, you always use Avogadro's number. You either multiply or divide by it. Okay, because if you're turning atoms to moles, you're just trying to figure out how many groups of 6.02 times 10 to the 23rd you have. It's like, if you had a whole bunch of, eggs and you divided by 12 to see how many dozen you had. You're basically grouping them into groups of dozens. So by dividing by Avogadro's number, you are dividing by 6.02 times 10 to the 23rd. You're dividing them into groups of that size. That's a mole. Okay. Whenever grams are involved, moles to grams or grams to moles, you need to look up the molar mass of the element that you're looking at. Okay. All right. So good luck with your work.